Our universe is a complicated place. But in the beginning, it was simple, very simple, according to Alexander Dalgarno.
The universe began at the Big Bang, so it began in a way that would seem not really conducive to the development of complexity, because in the Big Bang, all the particles are moving away from each other.
The Big Bang created a very hot soup of protons, neutrons, and electrons. The universe cooled, and the first element, hydrogen, appeared. Later, helium and hydrogen molecules were formed. When enough hydrogen and helium clumped together, gravity pressed them into a star. Stars fused heavier elements. When some of the stars eventually exploded, they forged and scattered even larger atoms, seeding planets with the elements of which we are made: carbon, oxygen, nitrogen, and others. Dalgarno was born in London in 1928. Equipped with a physics PhD from University College London and more than a decade of faculty appointments at Queen's University of Belfast, he came to Harvard in 1967, where he continues to work. After progressing through various leadership positions at the Harvard-Smithsonian Center for Astrophysics, he founded the Institute for Theoretical Atomic, Molecular, and Optical Physics, or ITAMP, in 1988. Hossein Sadeghipour now directs ITAMP.
I met Alex Dalgarno when he accepted me to be his postdoc in 1990. He is known as the father of molecular astrophysics.
There were observations of interstellar molecules, and if there were molecules, then there was chemistry. What I did was to make it quantitative. I constructed models, and I included in the models various reactions, and I calculated the rates of those reactions and used them in the model.
Dalgarno published a tremendous number of papers, dissecting most of the major steps needed to explain the universe's atomic and molecular complexity, and how that complexity could build planets and stars.
His scientific life involved the realms of the very big as well as the very small.
Dalgarno quantified key steps in forming planets and in understanding a planet's upper atmosphere.
He understood that we needed to know how molecules reacted with each other.
He laid the groundwork for understanding long-range atomic interactions, critical for research on how matter behaves near absolute zero. And his impact throughout the astronomy community was even broader than that. He was the longtime editor of Astrophysical Journal Letters, the leading journal in the field. He took the job because he thought he would learn about all aspects of astronomy. He found himself learning more than just science.
People regard their papers with loving care. I learned more about people than I did about astronomy. I did learn some astronomy too.
Moving from one problem to another in physics, Dalgarno knows how to nurture creativity and find good problems to solve.
Work hard, read widely, go to meetings, discuss, involve, interact with people.
And try to make the complex simple. Alexander Dalgarno was awarded the 2013 Benjamin Franklin Medal in Physics.